algebra. We have reached POFitty-Five, part one. Kind of our next step in studies of parabolas. So let's briefly run down all the characteristics of parabolas we've already talked about. What do you already know how to find? Give me one, Kylie. The vertex, that highest or the lowest point, right, where that curve happens. Ellen, the y-intercept, okay, and what part of the equation or what part of the expression gives us that? The C value, good.
The reflection point.
Reflection point, right, using that axis of symmetry, okay. Anything else? Okay, so the next characteristic we're going to talk about today, which is kind of the biggest one, it's one that you use most often, solving a quadratic equation. What this really means is to find the x-intercepts of the parabola. We don't really talk about the x-intercept of something too often. You know, in slope-intercept form, y equals mx plus b was the y-intercept and the slope, right? Parabolas, we start with the y-intercept and the vertex. But to solve a quadratic equation, we're looking for the x-intercepts, meaning where it crosses the x-axis. So think about what you know about an x-intercept. What's going to be our method here? What's going to be our strategy? What we're going to have to do, you can close your computers, what we're going to have to do to find the x-intercept of a parabola?
Find what y is?
Well, since it's an x-intercept, don't we already know what y is? 0, right? For every x-intercept of any line, any graph or whatever, y will always be 0 because it's on the x-axis. So our method here, what we're going to do is set y equal to 0 and solve for x. Set y equal to 0 and solve for x. And this is where these types of equations are different than anything you've ever come across before as far as solving. Because what do these equations have that is new to your solving process here, Rowan?
Oh, I was going to say, should you put a line to the 0?
Why? Well, your other option is y equals capital O. If you had to guess which one it is, which one? You are free to put a line through here. Well, of course it looks like an O, but I mean, given your two options, y equals 0 or y equals capital O, never mind. So what about 15 years of teaching? That's the first one. What about this equation presents a different challenge than other equations you've solved? Kylie?
The x is squared.
The x is squared is the first thing. What's the second thing?
There's no bx.
What do you mean there's no bx?
Down here it says.
Oh, we're not there yet. We're not there yet. Yeah, we're not there yet. We're just looking at. We're looking at the standard form. The x squared term. What's the other? It has to do with the bx though. The fact that there is a bx term, right? You've got two x terms, two x variables. You can't combine. One's an x squared and one's an x. So how do you handle that? Okay. So our solving procedures, if you kind of glance ahead, as some of you have, there are actually 3 different methods that we're going to talk about based on how the equation is written. Okay. Based on how the equation's written. But essentially, what we're doing, we're setting y equal to 0 and solving for x. So thinking about x-intercepts and what parabolas look like, you need to be open to finding 2 solutions. Remember when we talked about absolute value equations way back in, and you had to look for 2 values for x, and on the practice work and the test, that really kind of threw some of you. You're not used to finding 2 answers here. Why would you be open? Why should you be open to finding 2 solutions, 2 x-intercepts, 2 parabolas?
Because the parabola could go through the x twice.
Right. We'll draw a picture here. Parabola could come back up and come back down. You know, where it crosses that x-axis in 2 places, those are going to be 2 solutions. Okay? So I don't know, I guess what a word there. Crosses the x-axis twice. There's a picture of it. Sure, that works too. What type of parabola? When would you see a parabola having just one solution? What situation would that be? Yeah, Alex.
Oh, when the top of the parabola is touching the line.
When the vertex is on the x-axis, right? You're only going to touch it one time if that vertex is on the x-axis. And what would be an example or what describe a parabola that would have no solutions? Beckman.
One that doesn't hit the X or the Y.
Right. Well, it can hit the y.
Or not the
Okay.
X.
But yeah, if it comes down and the vertex is above the x-axis, it doesn't actually touch it, there are no solutions there, right? Or if it's a downward opening parabola, and again, that vertex doesn't touch the x-axis, it's going to have no solution. So you have to be open to any of these three situations happening. So you have to know what to look for. Okay? The first type of equation that we are going to tackle is y equals ax squared plus c. Okay? So as Aiden mentioned earlier, there's no bx term here. Essentially, what's happening is that b value is, now that's a zero going. Okay? 0x plus c. Okay? When b equals 0, when that b value is 0, it essentially eliminates that term, and we end up with the equation in that form, ax squared plus c. And the reason why I'm starting with this is because this is the most familiar method to solving an equation. You want to get x by itself. There's only one of them. Okay? So we use opposite operations. I highly recommend on a help sheet, you write this form of the equation, and you write method opposite operations. Okay? Well, that's going to help trigger kind of what you need to do here. So y equals 3x squared minus 75. We know that the y is going to be 0 by definition. Okay? It has to be. If we're solving for the x-intercept, y has got to be 0. So what's our first step? You get x by itself. What do we do? Max?
Add 75.
Add 75. Pretty standard opposite operations, right? Start with the constant. Add 75 to both sides. We get 75 equals 3x squared. What next? What next? Elliot? Not yet.
What?
Not yet. Okay, and then we're solving an equation, you work through perm dots backwards. We started with the constant because addition subtraction comes last. So next level, Noah, we're going to divide by 3. Okay? And 75 divided by 3 equals 25. And we're left with 25 equals x squared. And this is the new part now. Okay? As Elliot said, our last step here is going to be to root both sides. Why would we root both sides? Think about perm dots. Think about why we root both sides, yeah? Because it's the opposite of a power, right? The opposite of an exponent is a square root. By taking the square root of x squared, those operations cancel out. And you're left with x by itself. Okay? So this process is very familiar to what you've done before. That extra step, though, is that final rooting. Okay? And what's the square root of 25?
5.
Because we are dealing with parabolas here, and we need to be open to two solutions, you are correct. The square root of 25 is 5. However, what other number could be a solution to the root of 25 that because we're talking about parabolas, we have to include? Arlene? -5. Okay? -5. And there's a little mathematical symbol. If you don't want to write both numbers because that's so much work, it's this little thing here. Okay? An underlined plus sign. That means the positive and negative value of 5.
Makes it easier.
This symbol here, that plus minus sign, means the positive and negative value of 5. You could also just write, 5 and -5. But you do need them both. You do need them both.
Wait, but why is it?
Really?
-5
Okay.
-5.
The reason why it's both is because if we're looking for the root of 25, remember that definition is what number times itself equals 25. Well, it turns out that there are two different numbers that when you multiply them by themselves equal 25. Positive 5 and negative 5. So you need to include them both. POFitty-Five, I'm Jack. Yeah? Yeah. So you need to write them both. Okay? Questions so far?
Is that all we have to do?
That's it. Yeah, it's like a 7.
That's easier than the
Yeah.
last thing that we had.
Like I said, hey, I'm glad that you're thinking this is easier, but remember, we're starting with the most familiar. Just give it time here. Morning for you. Fine. Next one, y equals negative 5x squared plus 20. Again, we're going to start by setting that y equal to 0. Because since we're dealing with an x-intercept, we know it has to be equal to 0. And what's our first step going to be here? Someone new. Damien.
You minus 20 and bring it to the other side.
Yep, opposite operations. Okay? Negative 20 equals negative 5x squared. What x? Y.
You divide by -5.
Divide by negative 5. Continuing those opposite operations. 4 equals x squared. Final step.
Square root.
We're going to root both sides. That being the opposite of an exponent. Okay? The square root is the opposite of squaring. And that leaves us with positive or negative 2, I should say and. Positive and negative 2 as our x-intercept. If you want to put the plus minus sign, that works. Okay, that works. Max.
So whenever we do equations like this, it's always going to be two solutions.
Whenever you have an equation in this form, it's always going to be two solutions. Yes. Yes. The exception to that would be if you take the square root of 0. So it passes through the origin. It wouldn't be no solution. The square root of 0 would be 0. That would be the only exception to that. Aiden.
What's the test on this?
This unit runs through CO60, so the test will likely be end of next week at the earliest. Yeah. We have several multi-step objectives coming up, so we'll kind of see. Yeah.
We actually have like
Before we get too off topic, off tangent here, questions on this? Okay, go ahead and do the last one on your own if you haven't already. Take 15, 30 seconds. Compare your answer with the neighbor. Joyce, turn around. Neighbor said.
I already confirmed it.
What'd you get? Who's bold, confident, ready to share? Someone new that we haven't? Lissel. Yes, positive and negative 3. You do need them both. If you only put the positive value on a test, it will mark wrong. Okay? You do need them both. I didn't have to. Did anyone not get positive?
You're not doing it.
You did not?
I did, but
Wait, what if it's 2x?
Steven, go ahead.
I just wanted to see you do it.
Okay, next type of equation. Oh, you want to see me do it?
No, it's not.
Okay. The next type of equation is ax squared plus bx. So in this case, right, what this means is that in our equation, the c value equals 0. Okay? The c value equals 0. When that happens, you'll end up with an equation similar to this. Right? Which means that you already know what one of the x-intercepts is. 0. Right? Since the y-intercept is 0, that means that an example of what this problem might look like is it comes down through the origin and then back up someplace else. Okay? So in this form, you're kind of always given a freebie. one of them will always be 0. You're looking for the other one. And the method to do that is factoring out that greatest common factor. We had this objective in our last unit, right? Looking at the greatest common factor. So y equals 10x squared plus 30x. We know that y is 0. We can't use opposite operations for this because we've got those two x values, those two x terms we can't combine. They're different powers. We can't use opposite operations. We got to use factoring out the greatest common factor. What is the greatest common factor of 10x squared and 30x? 10x. Okay. So we're going to put that 10x out in front, and what's left is it goes in parentheses. We kind of did this in PO52 also, that first step, that long factoring procedure. Factor out that greatest common factor first. Okay, that's kind of what we're doing here. So if we take a 10x out of 10x squared, what's left? Just x, right? We took out the 10, we took out one of the x's, we're left with just an x. What if we factor out a 10x from 30x? What are we left with? Not 3x. We took the x out. Okay? You can check yourself to make sure you did this correctly by distributing the 10x back in and making sure you get what you originally got. Right? If we multiply 10x by x, we get 10x squared. If we multiply 10x by 3, we get 30x. Okay? Now, we're not done yet. Okay? But why we do this, here's the key here. Why we do this is we want to find the two values for x that make this equal 0, which essentially means what value for x makes 10x equal to 0? 0. Because if we make that first term equal to 0, does it matter what x equals in our second expression there?
No.
Because 0 times anything is what? 0. Okay? Because we know that 0 times anything equals 0, if we figure out what value for x makes this first term equal to 0, it's not going to matter what is in our parentheses, because 0 times anything gets us the 0 that we want. That's why one of your x-intercepts will always be 0, because whatever's on the outside here, that's where the 0 comes from. Okay? So one solution to this is x equals 0. I'll put it up here. Okay? The other solution comes from what makes this expression equal to 0. What value for x makes that equal to 0?
-3.
-3. Because if we make that second set equal to 0, does it matter what's out front here?
Oh.
No. 0 times anything is going to be 0. So the value that makes this expression equal to 0 is -3. Our second solution is -3. Okay? So when you factor out this greatest common factor, be thinking, you've got two expressions here. You've got what's in front, that coefficient, in this case 10x, then you've got what's inside of your parentheses. What value for x makes each of them, not both of them together, but each of them separately, equal to 0? Those are your two answers. Elliot, question. Okay.
So is it just always 0?
The first one is yes. One of them will always be 0. The second one will depend on what makes your parentheses equal to 0. Indeed. Yes.
Oh, I forgot.
Okay.
Wait, so it's -3 because -3 equals to 0?
Because -3 plus 3 equals 0. Yes. Arlene.
Can x in the parentheses be a decimal?
It can be. It can be. But you're going to typically want to write it in a fraction form. I've got a neat little trick that'll help with that. Because sometimes decimals can just be nasty. And you don't want to round if you don't have to. Okay? But yes, it can be a decimal. Yeah.
What if you do if there's no GCF or GCF?
If there's no GCF, we'll talk about that. There's always a GCF though. In this type of equation, there's always a greatest common factor. What will it always be? You'll at least be able to take out an x. Yep. Yes, we'll go over all three of these just because this is a kind of a new concept for you. The next one though, let's take out that greatest common factor. What's the greatest common factor of 6x squared and negative 15x? Kylie? 3x. Okay, so 3x goes out in front. And what's left in our parentheses, if you take a 3x out of 6x squared, you got left with a 2x. Okay? Essentially what you're doing is you're dividing 6x squared by 3x. We did this in CO50. Right? 6 divided by 3 is 2. X squared divided by x is an x. That's what it means to take out that greatest common factor. You're dividing that 6x squared term by the greatest common factor that you pull out. And what's left? Negative 15x divided by 3x. Rowan? Negative 5. Okay? Negative 5. And again, you can check yourself by distributing that 3x back in. 3x times 2x is 6x squared. 3x times negative 5 is a negative 15x. Okay? I'm going to write it a little bit different way than I did the first time here, so you can see it just the same thing, just explain a little bit differently. What we're looking for here is what value for x makes that expression equal 0. 0. There's your first one, right? X equals 0. Your second one, what value for x makes that expression equal to 0? And if you tell me, be prepared to tell me how you found it. Aiden?
2.5.
How'd you find it?
You multiply 2 times 2.5 and that equals 5, and then 5 minus 5 equals 0.
So you kind of went with the guess and check method?
Yeah.
Okay. Elliot, your hand was up. Do you also use guess and check?
I kind of just looked at it.
Came to you. Excellent. Arlene?
I did 5 divided by 2, so 5 over 2.
Okay, and why did you do that?
Because I figured you have to divide 2 by 5 to get your x.
Okay, so you're kind of, yeah, okay. Essentially, if we know that we want to make that expression equal 0, 2x minus 5, right? What value for x makes it 0? We can set that expression equal to 0 and solve it just like an equation. To do this, we would add 5 to both sides, then divide both sides by 2, which as a decimal is 2.5, or as a fraction is 5 halves, 5 over 2. Okay, either way works. There's a shortcut I'm going to tell you after we do the next one here. Okay, but if you're looking for what value for x makes this 0, one strategy you could use is to set the expression equal to 0 and solve for x. We didn't really have to do that here because it was such a mental, fact. What makes it 0? Negative 3, duh. Okay, when you have that coefficient in front of that x, it makes it a little more challenging. Let's do the last one. Negative 14x squared plus 9x. What is the GCF that we are taking out of that expression? 1x. Okay? At the very least, you'll always be able to take out an x by definition of what this equation looks like, right? It has an x squared term and an x term. You'll always be able to, at the very least, take out an x. And if all we take out is an x from negative 14x squared, we're left with negative 14x. If we take an x out of that 9x, we're left with positive 9. Okay? So, like the others, what value for x makes that 0? 0. Again, one of your solutions here will always be 0. What value for x makes that equal to 0? Aiden?
0.5.
No. Half of negative 14 is negative 7 plus 9 is positive 2. Bryn?
9/14.
Ugh, that's fun. 9/14. Bryn, how did you come up with that?
I did 14x, negative 14x plus 9 equals 0.
Okay.
The 9 of the 14.
So if we're looking for what makes that expression equal to 0, one thing you could do is set it equal to 0 and solve. Subtract 9 from both sides. So we get negative 14x equals negative 9. Divide both sides by negative 14, which is going to give us a positive 9/14 as an answer. Because that negative 9 divided by negative 14 cancel out. The signs cancel out.
I say we saved the last one.
Okay. Huh?
I say we saved the last one.
Yes, we're not going to go over the third method. Although, to be completely honest, you've done this before. The third method is just factoring. Remember PO51, PO52, when you factored equations? You've sort of already done the last one, but we'll save it for tomorrow anyway.
Yeah.
Okay. The shortcut for this method, for the second value for x here, can anyone see it?
Not just do.
Bryn?
It's the second value over the first value.
Close, very, very close. Bryn's noticing here that we've got a 2 and this negative 5 going on here, and our answer was 5/2. Here we had a negative 14 and a positive 9. Our answer is positive 9/14. So there is definitely a connection between that second value divided by the first one. There's one little extra step though, yeah.
Wouldn't you just do whatever the x term is over whatever the x squared term is?
Max, I saw the gleam in your eye that you're going one step further to the shortcut. Save it for now, okay? Because I want you to be able to pull out the greatest common factor. That's a skill I want to use. From this step though, yeah.
Second value over first value, and then you flip both signs.
Kind of. Basically, it's the opposite of the constant divided by the coefficient. The opposite of your constant divided by the coefficient. Our constant in 2x minus 5 is a negative 5. The opposite of that is a positive 5. Divided by coefficient 2, 5x. The opposite of a positive 9 is a negative 9. Divided by negative 14, which we have down here, is a positive 9/14. Okay? So once you get to this step, once you factor out that greatest common factor, kind of the formula, the shortcut here, is the opposite of the constant divided by the coefficient. Another option is to set it equal to 0, like we did, and solve it that way. Okay? Questions on the first or second methods? Kelly?
Would that shortcut still apply with like ones like the first one that we did, the 10x times 1 over your x plus 3?
Yeah, if we take the opposite of negative 3, or the opposite of positive 3, and divide by our coefficient 1, negative 3 divided by 1 still gives us negative 3. It does. You don't even use it there though, because your homework for tomorrow. I'm going to leave you with a little bit of homework. On part 2, POFitty-Five part 2, I would like you to do the first row and the third row. I'll try and get them all in one page here. The first row and the third row. So these 3 and these 3. Okay? You do need to show your work. Don't be thrown off by that second one where it doesn't equal 0. You can still solve for x here, can't you? Okay? What would your first step be? Subtract 80 from both sides. And now you're right back to a comfort spot. Right? So the fact that it doesn't equal 0, that's okay. Still work through the process. Kylie, you look confused. What can I help you with?
I don't understand how that works.
Well, what if I subtracted 480 from both sides? Right? If I subtracted 480 from both sides to get that 0, then on the left side, 80 minus 480 is negative 400, right? What would my first step be if I asked you to solve that equation? Don't you get there anyway? Yeah, right? So if it doesn't equal 0, it's okay. Okay? Still run through the steps. The bottom row, the third row, the last one you, 6x squared equals negative 12x. Don't be thrown. What do you need to do first?
Find the GCF.
Nope. 6x squared equals negative 12x. Move the negative 12x over. Okay? Move the 12x over first. Right? You have the tools in your toolbox to where if something doesn't look exactly like an example, you can still work with it. You just got to understand what's going on here. Okay? So don't just be thrown and give up and think about it. Okay? My equation equals 480. Oh, that's okay, because I have to move everything away from x anyway. You know? My negative 12x is on the other side of the equal sign. That's okay. Just move it over. Right? Okay. Bill 6. Homework tomorrow. Show your work, and we'll pick it up with the rest of POFitty-Five then. Questions, comments, concerns, complaints, comments, congratulations. Yes.
Nice try.
Thank you. I thought I went with the shirt today. Anything else? All right. That's how you math.
Don't forget to like and subscribe.